Now this is a quadratic equation in E1, and we know about a quadratic equation that ax square plus bx plus c is equal to 0. Then x can be found as minus b plus minus b square minus 4ac, and inside a square root by 2a. We can find the roots of this equation, quadratic equation, by this formula. Now if I look at to this equation, this is x square, this is bx, and this is c. So in this equation, I am having a equal to 1, b is equal to minus times WAA plus WBB. And what about C? C here is equal to WAA WBB minus WAB mod square. This is equal to C. So I can write that E1, this implies that E1 with E1 with a plus and minus, because we will have for the plus one root and for the minus another root, the value of E1. So E1 plus minus will be equal to minus b, minus times b, so minus minus become plus, and it is WAA plus WBB, this is minus b plus minus b squared. So it is with minus, but it is squared, so it will become plus, and it will be WAA plus WBB whole square minus 4 times a is equal to 1 and c is equal to this WAA WBB minus WAB mod squared. So this is our b squared minus 4ac, and this whole is divided by 2a. So a is 1, so it is only 2. It means I can write this whole divided by 2. And now I can further simplify this one. What about this value? This value will become WAA squared plus WBB squared plus 2 WAA and WBB. This is the a plus b whole square formula. A square plus b square plus 2ab minus 4 times this, 4 times WAA WBB plus 4 times WAB and mod square. Now look here, this is plus 2 WAA WBB, this is minus 4. So it will become minus. It will become minus 2 WAA WBB. If I combine it with this one, a square plus b square minus 2ab, so it will become a minus b whole square. So I can write that e plus minus 1 is equal to w, and I can write this one 1 over 2 here as a whole combined. So WAA plus WBB and plus minus, this will be WAA minus WBB whole squared, and then this is plus 4 WAB mod square, and this is inside a square root, right? This is inside a square root and bracket is closed. So now what I found, look here, if this value, if WAB is equal to 0, for example, in this, then it will come out because the square will cancel with the square root and it is WAA minus WBB. So it will come outside. And it can be very easily simplified with a plus minus symbol. With this we will find this value, but first we will confirm whether it can be 0, whether WAB can be 0. What is WAB? WAB is this one. When A is here, B is here, or B is here, A is here. So both are right. So look here, we have assumed this one, that F alpha is non-zero. Then the situation, the E plus minus values are equal to this. But what if alpha is equal to 0? When you say that this equation is equal to 0, alpha times this equation is equal to 0, it means either alpha is 0 or this is 0 or both are 0, right? This is the possibility. So if alpha is 0, then what will happen? If alpha is 0, then you will have to come back to your equations, and the equations are here, 1 and 2. If alpha is 0, equation 1 implies, look here, alpha is 0, so this is 0, this becomes 0, and beta WAB is equal to 0. Because this is 0, and beta WAB is equal to 0. Now what about this one? In this situation, if beta is non-zero, then it means that WAB is equal to 0. But what is meant by this thing, that beta is non-zero? What if beta is 0? Right? Like we are having two constants here. The states we know psi A0 and B0. It is the constant which will define their linear combination. It will give us a suitable wave function. So the alpha and beta values are important. Here we said alpha is non-zero, and we got the two values of E1. But this is equally possible that alpha is 0 as well. And equation 1 tells us that if alpha is 0, then WAB should be 0 if beta is non-zero. And what if beta is 0? Beta non-zero, we know that this one is equal to 0. But what if beta is equal to 0? Then, so come here. Beta is equal to 0. This will give you 0. And, but what about this one? If alpha is 0, then this is equal to 0. WAB is equal to 0. So when you say this is 0, and this is 0, meaningless, right? So we will go to the next equation. And here when beta is equal to 0, this term is 0. What about this term? This term is 0, and it tells us that alpha WBA 2 implies that alpha WBA is equal to 0. And if alpha is non-zero, if alpha is non-zero, then if alpha is non-zero, then WBA is 0. BA is what? BA is just the conjugate of WAB. So you are again at that situation, right? But if alpha is 0, then this value is non-zero because this is 0. And alpha equal to 0 situation we have already discussed. We have already discussed that what will happen to this one. So when this, if alpha is non-zero, then this implies this BA is equal to 0. But look at this situation. If alpha is 0, then WAB is equal to 0. Right? If alpha is equal to non-zero, 0, then WAB is equal to 0. And I can come back to this equation that in this condition, what will be the values? E plus minus, and this is equal E1. It will be WAA plus WBB and plus minus when this value is equal to 0. Then this one is gone. The square root will cancel with this. And here WAA minus WBB will remain. WAA minus WBB here. And whole divided by 2. So what about this one? This whole is divided by 2. This gives you E1 plus. Consider the plus symbol. When plus is here, then it will be WAA minus WBB. WBB will cancel. And 2 times WAA, but whole divided by 2. So 2 will cancel. And you will get WAA. And when this is minus, E minus 1, then this will be minus and this will become plus. So AA will cancel. And BB will become 2 times WBB and 2 will cancel. And you will get WBB. But what is WAA? WAA is psi A0 H prime psi A0. And what is WBB? Psi B0 H prime psi B0. You got 2 values, E1, E plus and E minus of E1, 2 values. But look here, is this equation different from this equation? This equation is not different from this one. Because in this equation, the first order correction is the unperturbed states in Hamiltonian. The perturbation is applied on them. Look here. What was psi A? Psi A and psi B, these were the 2 different states. We wrote them in this combination, psi 0 alpha, psi A0 and beta psi B0. So if this value means the cross term value, the WAB value, if this one comes out to be 0, and when this one comes out to be 0, when the alpha is equal to 0 and beta is not equal to 0, then this is equal to WAB is equal to 0. So it means that the first order correction to the energy for the perturbed states, for the unperturbed states, but the states are degenerate, we have removed the degeneracy because we got two values of E1. This is which was required. We got two values of E1. You see here H0, A0, same value here and same value here. But now the H prime when operates, we are getting two different values. So it means that degeneracy has been left. We have removed the degeneracy. It is like, let's say you are having one thread and the thread is, you can say, twisted, is the usual thread. If this thread is made of one wire, one thread or two, what you do usually? You untwist it. You slightly perturb this one and then you see that yes, it is made of two threads or it is the one thread. You do that thing all the time. Like for example, when you are having a currency note and it seems one, but you just slide it over the other, that whether they are two or not. You are just perturbing their states. Is a crude example, not the quantum mechanical example, but usually in classical mechanics we do things like that. So here, this E1, this was the energy which was composite, like possessing two states energy. Because E0 is of the two states, you have seen here, H0, psi 0, and it gives you E0, one energy. And here you got, means E0 of the one state as well as of the other state. So it is like this. In your book, this figure has also been given to you, and it is like this. That, let's say these are the values, lambda, and this is the energy E on this axis. So we were having the value A0 here. This was a single value. But as we applied the perturbation theory, then they split it like this. And it has become plus 1 here, like plus 1 here, and minus 1 here. Right? Means you have splitted the level. This level was coming as 1, but the perturbation just splitted it into two values. And the whole role is played by W, A, and B. If the cross terms are the term which is combining the two, this one, which is combining the two, if this term is equal to 0, then you have lifted the degeneracy. And why this degeneracy has been lifted by considering this term equal to 0? Because we were lucky to have psi A0 and psi B0 such states. Okay? Psi A0 and psi B0 is such states. And rest we will explain in the forthcoming lecture. In the forthcoming lecture, we will start from here. That why we have lifted the degeneracy. What was the role of psi A and psi B in lifting up this degeneracy? And we will also cover a theorem and a problem on this one. The example which is in your book, we will cover that one as well, and this will complete our degenerate perturbation theory. Okay, thank you.